Thank you all for coming at the end of a several day-long conference post-lunch. I will try to keep this entertaining enough to prevent people from napping. This is faster, cheaper, easier. Choose 3. Automatically optimize DBT at scale. If you're trying to do something else, you're in the wrong room. This is a tech talk. We're going to tell you about what we're doing to help people optimize DBT at scale and how it works. Hopefully there are some good takeaways. I'm going to be talking about the technical details of 2 cool things that we are building at Espresso AI that are specifically aimed at DBT. First, I'm going to tell you a bit about who we are and why we're doing this at all. And then I will talk about automatic query incrementalization, as well as DBT job scheduling. To give people a couple minutes to keep walking in, though, how many people here use DBT with Snowflake? Okay, quite a few. How many people are on BigQuery? Redshift? Okay. Other? Okay, cool. That is roughly the distribution I expected based on people that we're talking to. So pretty cool. Okay, who am I? Why am I here? I am one of the founders of a company called Espresso AI. We use generative AI to automatically optimize Snowflake. Before I started Espresso, I used to work on systems performance at Google Cloud. Also worked on machine learning and natural language processing at Google Search. And I've done some research on reinforcement learning for systems optimization with DeepMind. The very initial idea for Espresso AI was using LLMs to automatically optimize code. Pretty quickly, we honed in on Snowflake as a good first place to start with code optimization, specifically with SQL optimization. For those of you who do use Snowflake, you won't be surprised by this. Our customers are typically seeing their Snowflake bills grow 20 to 30% per quarter. We save customers up to 70% on their bill automatically. It's actually up to 80%, but like people already don't believe the 70% number, so I decided to stop incrementing it in our copy. For those of you who don't use Snowflake, you should keep in mind that a warehouse in Snowflake is what most people would think of as a cluster. I kind of use those 2 interchangeably, but cluster is the more kind of reasonable term. So how does the product work overall? We have a warehouse optimization agent that manages cluster autoscaling. You set this up by giving us a Snowflake account. We train on a bunch of your historical data to understand what we should scale and when. And then we take over that management transparently in the background. This works really well for DBT, but it's not DBT specific, so not really going to be talking about it too much today. Our DBT specific features and some other more advanced features use a SQL proxy. So you would send your workloads to us, and then we can make decisions on routing and query optimization, query by query. So basically, we grab things in flight. We may speed up the query if we think we know how to do that, and we change which warehouse it's running on. This is a visual representation of what a SQL proxy looks like. Okay, so why are we doing DBT-specific stuff? DBT is hands down the most popular tool across our customers. We see many users with close to, if not over 50% of their compute load coming from DBT. So it seemed like a very promising place to start optimizing stuff. uh, running DBT jobs faster and cheaper is going to be really impactful across our user base. We've also found one really simple way to speed things up if you're using DBT specifically on Snowflake. I will talk about this at the end of the talk, so you have something concrete. Stay tuned. Okay. Part 1 of 2, query incrementalization. How many people have incrementalized queries before? Okay. This is super effective. You can make things run faster and cheaper with incrementalization. This is basically like algorithmically making your jobs run faster. We've seen users where incrementalizing one query in their pipeline might make things run 90% faster. Query incrementalization, for people who haven't heard of it, means writing your queries in a way where if you have ELT going, instead of needing to sync the entire database each time, you only sync new rows. So really obvious example is if you have just a select star, instead of having to select the entire table from Postgres or whatever and copy it over to Snowflake every day, you are copying over just the new rows that landed. That's pretty easy to do in DBT. So this is an example that I took from a blog post that Tristan wrote a while ago. Basically, for simple enough queries, you can just specify, hey, this is the event time, and just update the new stuff. You also have to think about things like backfill, so it can get a little bit more complicated. But in practice, it's really straightforward. However, as soon as the queries get any more complicated, you really start having to put in a lot of work. So you can start having to deal with joins, multiple joins, aggregations, filters, subqueries. All of this stuff, you need to figure out, how do I do the bookkeeping to make sure that everything is correct, right? So this is what some of the math for that looks like. The bottom thing there is kind of an elaboration on joins. So like, you kind of want to join the new part of table A to the full table B, and then the new part of table B to the full table A, and then join the new thing, blah, blah. So this stuff is really like, you can do it by hand if the gains are good enough, but it's error prone. It adds a lot of maintenance overhead. The next time you go and edit this query, you now need to redo all the logic and recheck it and so on. In general, it's just way easier for a computer to do this than it is for a person. So that's exactly what we're doing. We are building a automatic incrementalizer into our proxy that is going to take DBT workloads and be able to add all of that math. It's not going to be able to do this in every case right out of the gate, but we are basically building this to like compiler level accuracy, where when it does do it, you can be confident that it is correct, it is doing the right thing. One thing I wanted to mention here, so DBT just announced something called micro-batch incremental models. They're really cool. They were, I think, announced at some point in the last couple of days. There's also some documentation online. These cover, for existing queries, things like how do you do backfill and some other edge cases. So one is, this is just a really cool feature that you should take a look at if you have existing incremental models. And two is, we can leverage micro-batch annotations to kind of do this stuff in a more sophisticated way. So we're excited to take a look at that and start adding them to our pipelines. I decided to do 2 Q&As because everyone will forget the first part of this talk by the time I'm finished with the second. So we can take a couple minutes now. Anyone have questions? And I'll repeat the question. So, yeah. Yeah, so the question is, couldn't the automatic incrementalization work outside of Snowflake, and could we support it? Yeah, none of this is Snowflake specific. I mean, there are some like dialect specific things we might get into, but yeah, generally this would work broadly. And we do plan to extend to other data warehouses and backends in the future.
So yeah, like as you said, one of the more complex things with incremental tables, especially the more complex one, is when you do need to do a backfill, you often think quite hard about what to do about that. Are you saying that if you just write the select statement, just as if it's not an incremental query at all, and you will just always kind of be able to handle even the backfill cases when, I don't know, the pipeline's down for 3 days or something and it comes back up? You can handle that, those kind of situations?
Yeah. So the question is, how do we actually handle backfill and other edge cases? So one answer to that is if you have something like microbatch set up where you have existing backfill logic, we can go off of that. The more general solution we're looking at for backfill specifically is looking at like machine time when the database was written and when your original data was written. So there is this like everything is time stamped, but to a certain extent, the timestamp that you get is just like it might as well be a string. It's just like something that the user put in. So we're coming at this from more of a like systems consistency perspective, where it's not that we're guaranteeing that there isn't more backfill to be done later. What we're trying to guarantee is this will return the same result as if you had run the original query. So yeah, like the answer is yes. If you wanted to do a full fill today, we should be able to go back and extrapolate, okay, here are the things that were physically written to the source database, since the last time this was run. We should be filling out all of those, regardless of, the timestamp that they might have in a user timestamp column or anything like that. Other questions? Cool. Oh, yes. Uh, yeah, so the question is, do we know what should be incrementalized? We're trying to automate as much of that as possible. And this is like, so actually, I guess this is a good time to pitch. We are looking for beta users to be able to answer questions like that more clearly. With beta customers today, it's been pretty obvious and automatic so far. But I would have, we're trying to keep that way. I would have more confidence in it when we have like, 15 people using it or something. And we feel like either we have really good coverage or we've had to go back and add some manual annotations. Cool. Scheduling. So this specifically, we are talking about offline scheduling for your DBT jobs. So when you run a DBT job, you are going to get a DAG of queries for it. For people who are not familiar with graph theory, a DAG is a dependency graph, or specifically a directed acyclic graph. So it just tells you which queries depend on which other queries. When you have a specific DAG, there are going to be many different ways to execute the different queries in dependency order. And we are working on using scheduling theory to find faster execution plans. So basically, execution plans that can leverage the dependencies to run more things in parallel and get you your result faster. Sometimes it's also cheaper. Sometimes we can actually run more things in parallel in a way that also increases utilization per cluster. This is an example of a typical DAG from a DBT job. And I'm going to be spending the rest of the talk going through this node by node and explaining whatever. Here's a bit of a simpler example that we can work through. It's got 6 queries. For simplicity, you can just assume that every single query takes 1 minute. If you just ran this on Snowflake, here's basically what you would get. Again, there's some simplification. Snowflake has some parallelism built in. But effectively, it's going to shove everything onto the same cluster. And it is going to take 6 minutes to run this on the single cluster or the single warehouse. If we take a look at the DAG, it's pretty obvious that you don't need to do that, right? You can run A and B in parallel. You can probably get some parallelism out of D, E, and C. And specifically, the optimal thing you can do is this. So you can run D, E, A, B in parallel. You do this across 4 different clusters. And then you run C and F after that. And you basically are paying the same amount. You have 6 minutes of runtime here, but it actually runs in 3 minutes. If you're more interested in cost than time, you can often size your warehouses down at this point and bring it back to the original 6 minutes of runtime, but save a little bit on cost because things don't parallelize perfectly. Again, depends on the details. If you're interested, here are some papers in this field. We had someone come on with working on a PhD in scheduling theory and kind of tried applying this. This example is very straightforward. It's like harder to understand what you are meant to do here. So there's all sorts of graph theory that you can throw at it. So if you need some reading for the plain back, these are some classic papers in the field. Roughly speaking, we see speedups here around 30%. That's often similar to what you get by stepping up a warehouse size across a job. Again, it can really vary widely. I was giving a practice talk, and someone asked me how any of this uses ML at all and why we have AI in our name. So I thought it might be helpful to explain that. We use large language models to predict things like query preprocessing time, runtime, scaling, and concurrency. These are all the sorts of things that you want to know to be able to understand, which size warehouse do I run this query on? How many other queries can I put on the same warehouse? If I scale this up, am I going to be running everything twice as fast, or am I just going to be paying twice as much, and so on? Preprocessing time, so this is things like compile time, time to do back-end file system stuff, and so on. Let us pipeline queries. If you don't do this well, you can often find that your clusters are sitting idle, and you're just sort of paying for preprocessing time and no actual workload. This is a little bit like CPU pipelining. You want to make sure that you have enough work coming up to keep your expensive CPUs running efficiently. Runtime predictions, that's just obviously really helpful. Also tells us which queries can we incrementalize? Is the incrementalized version of this query actually meaningfully faster? Scaling and concurrency, so these are both variations of parallelism, help us reduce runtime, increase utilization. So you want to make sure that you're running queries on warehouses that are the right size. You want to make sure that you are utilizing as much of a cluster as you can so that you're not just paying for machines and cores to sit idle and spin and do nothing. In general, we are putting all of this together and building an ML-powered runtime scheduler. So unlike the sort of offline scheduler that I described, this is an online scheduler that, as each query comes in, we'll be able to take a look at what you're running and where, see what's underutilized, and start routing queries accordingly. This is similar to how Google runs their data centers with Borg. This is also similar to the Kubernetes scheduler, which is the same sort of technology. Yes, that is what I said. Okay. DBT optimization advice, if you're specifically on Snowflake. If you take one thing away from this talk, try increasing your thread count. We found that this was extremely helpful with some of the users that we were talking to. So DBT's default, which is sensible in general, is 4 threads. However, what that means is if you have 4 queries outstanding, your job will just block. And it's easy with Snowflake in particular to have those queries blocked on preprocessing, or if you're on a larger size warehouse, just to be really underutilizing it. Most jobs benefit from more parallelism, sometimes a lot more. We've seen this effectively go up as high as 64 or 128 and still see gains, so good thing to experiment with. The reason that this works really well for Snowflake as opposed to maybe something like Postgres is Snowflake will queue stuff for you. So if you're sending everything to one warehouse, if you're on a standard warehouse, there's basically no downside. Like, you can send it as much stuff as you want, Snowflake will queue it up, and you should just go very, very aggressively. If you're on a multi-cluster warehouse where you're actually spinning up more compute on demand, you should try to keep increasing parallelism until you see increased costs. The details here kind of vary. Like, 16 threads might work great, but 32 threads spin up like, a third or fourth cluster that's not really well utilized, and then you start seeing costs increase more than runtime. Doing this can increase speed roughly as much as increasing a warehouse size, and it's free, which is great. You can stop by our booth. We have swag. We have a team that can talk to you and tell you more about what we're doing. Certainly, if you're on Snowflake and you're looking to cut costs, reach out. We're very happy to help. It takes about 10 minutes to set up our software. We can tell you up front how much we're going to save you, and we bill back based on savings, so it is 100% free money back for you. If you want to try the DBT beta features, we would be really excited to partner with you. It's always great to talk to people who are like really into what they're working on, which I think everyone at the conference kind of falls into, and sort of have a good feedback loop going back and forth. This is probably the best place in the world to find Power DBT users. Yeah, and if you don't have time, if you're to stop by our booth, if you're running out to catch a flight, you can email me at ben@espresso.ai. Questions?
You might think that Snowflake is doing some of this stuff for you under the hood. But, let's not talk too much about that. Do you think that BigQuery is doing this automatically under the hood?
Do I think BigQuery is doing this automatically under the hood? I know stuff about that, so I can't actually answer that question. Sorry.
Maybe just one quick follow-up.
Yeah.
The 30% speed, like time saving on scheduling.
Yeah.
What's the equivalent cost saving for those, like, specific to just scheduling?
Yeah. So the question is, we're seeing 30% time savings. What's the cost savings equivalent? Often closer to 10%. So a lot of the time savings is by running more stuff in parallel rather than necessarily running with less compute. If you can step down a warehouse size, that can go up to more like 10 to 20%. Not to say that there aren't workloads that can benefit from this disproportionately, especially on multi-cluster, if you hit one of those edge cases where the Snowflake defaults are just like spinning up a half-used cluster, you can see higher ones, maybe 30, 40%. But yeah, it's the wall clock savings is usually significantly higher with driving more parallelism than CPU time. Yes?
Is there a way to balance? Maybe I don't care about speed. I care a lot about cost. Can I also tune it for save as much money as possible, but let it run for an hour?
Yeah. So so the question is, can I tune it for cost instead of speed? The best way to do that is with warehouse size. So run it faster on a smaller warehouse. If you have a specific SLA in mind for your jobs, we can search over like the so you can sort of maximize you can minimize cost subject to a runtime constraint. So that's really easy. In general, you would do this with integer linear programming, which is kind of how we do it under the hood, or one of the ways we do it under the hood. So yes, there are ways to do it. A lot of that in practice means making sure you're not parallelizing so much that you have one query running at a time. So yeah, like increasing thread count is another good answer. Like increasing thread count on a warehouse with a single cluster, and just if you're seeing a bunch of stuff queue, it's probably going to be more or less cost efficient. It might just take a really long time.
That's what I'm thinking. If
Yeah.
I run it once an hour, I don't care if it runs in 5 seconds or 6 seconds.
Yeah.
It's going to just sit there for the 59.5 minutes anyway.
Yeah, if you're running something once an hour, you should probably, and it's running in 5 seconds, just drop down to an extra small, increase thread count, and you can have it like go. Where people, I think it's quite common for us to see like, well, I'm running this in 45 minutes and the SLA is an hour, but I'm not comfortable, but there's some variance, so we really have like a 10% buffer, and then it's a little bit more of an optimization problem. Yeah, saw a hand over there. Yes.
Do some changes to the default number of threads in Snowflake, and if you do, if you can share what kind of metrics can be used for this kind of decision.
So the question is, do we change the default number of threads in Snowflake? Snowflake will kind of just run the number of things at a time that it wants. There is a variable for this. It's like max concurrency level. It's not super clear that this does a whole lot. So the default is set to 8. You'll see plus or minus, 8 things running. In general, like you probably want Snowflake to run as many things in parallel as it can, just because it's reasonably conservative about hardware utilization. The sorts of things that you might see, obviously, like latency metrics are a good thing to keep an eye on. There is a new set of query cost attribution metrics that they just released. That seems really promising. I don't know how accurate they are. I haven't had a chance to look at them, but it seems like an interesting source of information. The third thing that we like to keep an eye on is cache hit ratio. So in particular, if you're running a bunch of unrelated workloads on the same cluster, you don't want to see cache thrashing. It's uncommon for that to happen. So if you're just, again, sending over a bunch of dbt queries that are in a related job, it's probably going to be fine for your cache. For our online scheduler, where we start mixing workloads together from otherwise different warehouses, we try to keep job affinity in mind and generally keep an eye on the cache hit ratio. Yes?
Are you integrating only with dbt, or can be working as a general proxy for other applications?
Are we integrating just with dbt, or do we use other stuff? Yeah, we'll integrate with pretty much anything. So we have BI tools are the other big source of load. In general, like for the proxy, it works best if you send us all of your traffic. And the long tail can really have outsized costs, right? Like you can have users sending a 1-second query that then you end up paying 60-second minimums for. Whereas if we know that that's what's happening, we can route it to a different warehouse and see really high percentage savings. Yeah, and we just work with customers to, most things it's a simple URL change. So you're literally sending things to like your account.espressocomputing.com instead of your account.snowflakecomputing.com. We work with people on a tool-by-tool basis and help them switch things over. 3 seconds for one more question. Yes?
Do you have any espresso at your booth?
Do we have any espresso at our booth? We have chocolate-covered coffee beans. So yeah, come by and grab some. Is that still true? No, we don't have any more chocolate-covered espresso beans. Sorry. All right. Thank you all for coming.